Hello everyone, welcome back to my channel. So today we will have a short discussion about special theory of relativity and we will have more problem solving on this topic, okay? So that your concept will be clear. Special theory of relativity is in this topic, it's very important that you solve lot of problems because when you will solve then only you can understand which one is the S frame, which one is the S dash frame, you know, and you can relate which formula to be used, okay? So, without going too much into the theory of Michelson model experiment and the null hypothesis and all those, I will just directly jump to the formulas and to the sums. And I hope your way of approaching the questions related to this topic will be clear. Okay. So this topic is in GATE, IIT JAM, CSIR NET. Almost in every exams we get questions from this topic. Okay. So let's start. Initially I will give you some formulas. One is about Galilean transformation. Okay. Now according to Galilean transformation, if we consider two frames, one is the S frame, okay, and one is the S dash frame. Okay, the coordinate of S frame is x, y, z and t, and the coordinate of S dash is x dash, y dash, z dash and t, and this S frame is at rest and S dash frame which is moving with the velocity v. Suppose this velocity v, the object is moving only along x direction, then according to Galilean, the transform coordinates can be, that is x dash, that is in S dash frame, is related with the coordinates of S frame, as x dash is x minus vt, y dash and z dash are same, and t dash is also same, which was later told by Einstein that no, our time will also change. Okay, and then comes our Lorentz transformation. Okay, and then Michelson-Morley did an experiment saying upon Einstein's assumption, but then later it was proved that Einstein was right. So now according to Lorentz transformation, our transformed equations are, this is the S frame, this is the S dash frame, and this frame is moving with the velocity v and the coordinate, suppose this is the point P, then similarly we can say that x dash equals to x minus vt, but here comes one additional term, that is 1 minus v square by c square, y dash is y and z dash is z, and our t dash, that is our time, this time is not equals to time, but our time t is also, t dash is also changing, and this is the relation. Okay. Yes, if I want, I can also give you the brief theory of how this formulas has arrived and a lot of stuff regarding this, the whole theory, and I can also deduce this formulas and all, and velocity addition formula later I'm going to tell. But see, this is December, 19th of December is going on. Those who are preparing for JAM and those who are preparing for CSIR NET, you don't have much time. You have 1 month and like 10 to 15 days, right? So now your focus should be on understanding the question properly. Whenever you're reading a question, understand what they're asking and which formula to be used, the concept behind that, and you need to get a you need to solve the question and you will get an answer. This is your process right now, and to revise the formulas, right? So that's why I'm not going too much into the theory. Yes, later we will again have a video in that we will discuss only the theory behind this. Okay, so these are the formulas for Lorentz transformation, which formula we will use. Okay, also there is some velocity transformation equation. Similarly, just in this only we can say that our, if this is our x-axis, x dash, and this is our x-axis, and you can say this is y and z dash. Okay, So in this also we can say our velocities formulas, like we know what Vx dash, we can clearly say it is dx dash dt dash. You can differentiate and you can see you will get this value as Vx minus of V 1 minus Vx V by c square, where Vx is the velocity in the s frame and V is the velocity by which s dash frame is moving. Okay, Vy dash is Vy root 1 minus V square by c square. See, the denominator part is same. Okay, it's very important that you should remember these formulas exactly. Okay, you say this for Vy and Vz, the numerator part is basically the same, only instead of Vy we are getting Vz, and the denominator part is same for all the three. Okay, so this is my equations for Vx dash, Vy dash and Vz dash. Now you may have a question, what about if we need to find the velocities in the s plane? Then what will be our equations, right? Yes, then Vx is Vx dash plus V. See, this minus will be get converted into plus. Not converted means I am just telling you just to remember. Okay, you can, if you do this dx dash dt, or if you do this dx dt, you will get this formula. Now Vy is equals to Vy dash. See, we know that Vy and Vz, our numerator part is basically the same, only Vy and Vz they are getting interchanged. Okay, and the denominator part is same for all the three. For all the three, the denominator part is same. Also, we will have the transformation equation in our x, y, z and t. Okay, say this here in case of Lorentz transformation equation here. Yes, again if you see x, this can be written as x dash plus vt root 1 minus v square by c square. This is same, and t will be t dash plus vx by c square by root 1 minus v square by c square. Okay, see, these are the formulas which we are going to use. Okay, so apart from this we have two more formulas. One is our length contraction and second is our time dilation. Okay, time dilation. See, length contraction in the moving frame if the length is L, and in the rest frame if the length of a rod, suppose the length of a rod, okay, which is in this frame and which is moving with the velocity v, then in the S frame, this is in the S dash frame, S frame, we will see the length of the rod as L naught 1 minus v square by c square. Okay, length, that's why contraction, because this term is always less than 1. So from S frame, an observer will observe that the rod's length is getting contracted. Okay, now time dilation means just the opposite. In here we will get the time t, sometimes it is written as delta t also you can say, or time t also you can say. The formula is same, and t naught is our time in our S frame. Okay, that is also called the proper time, also called the proper time. And clearly here we can conclude that our time that is in the moving frame is greater than our time that is at the rest frame. Okay, so now first we will do some problems related to this formula. Okay, of a muon in its rest frame to be 2 into 10 to the power minus 6 second, its lifetime in the lab frame when it is moving with a velocity of 0.95 c is, okay, options are 6.4 into 10 to the power minus 6 second, 0.62 into 10 to the power minus 6 second, 2.16 into 10 to the power minus 6 second, and option D is 0.19 into 10 to the power minus 6 second. Okay, see the concept. Mean life of a muon in its rest frame. So if this is the S frame, we call this as the rest frame. Here the mean life is given 2 into 10 to the minus 6 seconds. So in the rest frame we denote del T naught, or you can also say as T naught. Okay. And in the lab frame, which is moving with the velocity of v, that is equals to 0.95 c, where time is denoted by t, and we need to find the lifetime in the lab frame. Okay, basically we need to find t. So our formula is what? T is equals to t naught root 1 minus by root 1 minus v square by c square, where T naught is what? T naught is the lifetime in the rest frame, that is in the S frame. Okay. So the basic thing which you need to understand is that which one is my rest frame, which one is my moving frame. Okay. So clearly from here you can understand that in the rest frame, the lifetime, that is mean lifetime of the muon, that is T naught, which is denoted by T naught, that is given, and another frame which is moving with the velocity. So this is my moving frame, so this is my S dash frame. So we need to find the T in S dash frame. So T is equals to T naught by root 1 minus v square by c square. Now we have to substitute the value 2 into 10 to the power minus 6 second root 1 minus 0.95 c square by c square. Now calculation part, 2 into 10 to the minus 6 by root 1 minus 0.95 c will cancel out, and this one value I will do with calculator, and I am getting the value as 2 into 10 to the minus 6, 6.4 into 10 to the power minus 6. So this is my answer, what I am getting after calculation. So this is option A. Yes, exactly, option A is matching. So this answer is the correct answer. Okay. Okay. We will go with sums so that we can understand the concept also, and relativity is such a topic, until and unless you will do problems, you will not understand the concept. Okay. More the problems you will solve, more your concept will be clear. So all the questions which I am discussing, these are all previous year questions of different examinations. Okay. See, next question is what? Next question is also related to this above formula only. Another question so that your concept will be more clear. See, rate of a clock in a spaceship Surya Sakti, this is the name of the spaceship, is observed from Earth to be 3 by 5 of the rate of the clock on Earth. The speed of spaceship Surya Sakti relative to Earth is. So this is the question, and the options are what? Options are 4c by 5, 3c by 5, 9c by 10, 2c by 5. Okay. Now you understand the question. What is saying? Rate of a clock, that is the time, in a spaceship Surya Sakti. Spaceship Surya Sakti means our S dash frame is what? The spaceship, because this is moving, right? And our Earth is the S frame, which is the rest frame. Now is observed from Earth, that is from the rest frame, it is observed to be 3/5 of the rate of the clock on Earth. That means T naught is equals to 3/5 T, right? Because T naught is what? Which is observed in our rest frame. Now here our rest frame is what? Here our rest frame is Earth. So T naught equals to 3 by 5 T. Many books, this formula is written as in this way: delta T, that is equals to delta T naught by root 1 minus V square by C square. Now you can also use T, you can also use delta T. Okay, so I am using delta only. Now you see, this is what T naught is always in my rest frame. So here my rest frame is what? Earth. Now from Earth, it is observed that the rate of the clock is what? 3/5. We need to find the velocity v by which the spaceship is moving. Fine, so we will use our formula delta T equals to delta T naught root 1 minus v square by c square. Now delta T naught is what? 3/5 delta T by root 1 minus v square by c square. So this delta T and this delta T will cancel out. We will get 1 minus v square by c square equals to 9/25 squaring. So 1 minus 9/25 is equals to v square by c square. So this is 16/25, that is equals to v square by c square. So I'm getting v is equals to 4/5 c. Now let's see which answer is matching. Answer E. Option A is our correct answer. Okay. Okay. So this question is regarding our velocity addition formula. See, a car is moving horizontally with speed c/2. Okay. A car is moving c/2 and a ball is thrown from the car with speed c/2. Okay. A ball is also thrown with speed c/2. Now in the direction of from the car with speed c/2 in the direction of the ball as seen from ground. Okay, so there is an observer who is seeing that this ball is being thrown from the car. So this is our S frame and this is our S dash frame. Now what is the velocity of the ball as seen from ground? So who is seeing from the ground? This man, right? So we need to find Vx. See, I will tell you one technique how to understand which we need to find, because sometimes student gets confused that we need to find Vx dash or we need to find Vx. So I will tell you that how to judge that. Okay, now here they have asked what is the velocity of the ball as seen from the ground. Ground means the observer is seeing. So here we have to find Vx. Okay, so Vx is equals to, we know what, Vx dash plus V and 1 plus Vx by c square. Here our motion is along x axis, so we will consider our Vy dash. Here Vy and Vz equals to 0. Similarly Vy dash and Vz dash is 0. Okay, so here Vx dash is what, c/2 and V is what, c/2. So 1 plus c/2 into c/2 by c square. So if you calculate this, what you will get is c/2 plus c/2, that is c. 1 plus 1 by 4, that is 4c/5. Obviously the velocity cannot be greater than c. So 4c/5. So our answer is what? Vx is 4c/5. Okay. So today we will stop here. In the next video we will do problems. We will do questions regarding length contraction. Okay. More problems on velocity addition formula, Lorentz transformation, and we will also study about Doppler effect. Okay. So thank you for watching. Keep studying. Okay.